so we're going to look at operations with functions. So we're going to evaluate some functions using variable expressions or variable inputs. And we're going to look at multiplying, subtracting, adding, and composition of functions. So first off, we have g of x equals 4x minus 5. We're going to find g of x minus 1. So we've seen before where you have to evaluate using g of negative 3, and we would take that negative 3 and plug it in for x. But here what we're doing, this whole expression is going to go in for x. So we're going to plug it in parentheses so that we can make sure that we're using the operations with this entire expression. So g of x plus, or x minus 1 is 4 times x minus 1 minus 5. So we literally just substitute it in for the x. Whatever this is, we put it in for the x. The x goes away because we're substituting it, we're replacing the x with that. And then this is just a matter of simplifying. Using the distributive property, we will get 4x minus 4 minus 5, and then we can combine like terms and get 4x minus 9. So anytime that you're evaluating a function for a variable expression, it's just like evaluating it for a number. You just replace the x in the equation with that new value, which in this case is the x minus 1. Another note here, a lot of times we see f of x, but you can use, it could be g as a function of x, q as a function of x, r as a function of x, etc. So in this example, we have p of x and r of x, just two different functions. This is pretty straightforward, the operations with functions. This is p times r of x, so it's just multiplying the two functions together. So you would literally just take 5x minus 1 times the negative 3x. And multiplying, this will give us negative 15x distributing plus, x squared, and then plus 3x. So we just literally multiply the two functions together. This times this. With subtracting, similar. P minus r would be 5x minus 1 minus the negative 3x. Notice that I'm putting that in parentheses. I'm subtracting a negative, so just be careful with signs. And then combining like terms, that'll become plus a positive, so I'll get 8x minus 1. Adding these together, same thing. Just take the 5x minus 1 plus the negative 3x, combine your like terms, you get 5x minus the 3x is 2x minus 1. And that is your answer for that one. And then you might see something like p plus r of negative 3. What you would do in this case is find p plus r, which we just did, and then evaluate that for negative 3. So we're taking that negative 3 and plugging it in for the x. So that would be 2 times negative 3 minus 1. You could also go back to this step and plug it in there, but it's a lot easier if you find the operation first and then plug that into that resulting expression. So then simplifying this, 2 times negative 3 is negative 6, minus 1 is negative 7. And that's it. So that's operations, except for compositions. Composition is the hardest one, so we're going to spend a little bit more time on that one. So composition of functions, we just saw multiplication. Multiplication looks like a dot, so p times r. Composition can be written in two different ways. You can see f of g of x or f of g of x, like a little circle. That looks like more like an O, but like a little circle there. So it's not a dot, it's a little circle. These mean composition. My favorite way to see this is this one, because you can kind of see it's like f is a function of g of x. So instead of being f of x, it's f of g of x. So when you see this, what you do is you take this g of x, this expression, and you plug it in for the x in the function f. So it's kind of like what we did in that very first example where we took that g of, I think it was x minus 1 and plugged that in for the x. It's a similar thing, but this is what that means. Now if it was the reverse, you could also see g of f of x. That means you'd plug the function f of x into g. So let me show you a couple of examples. If we have f of x equals x squared minus 2 and g of x equals the square root of x plus 1, and we want to find f g of 2. What we're going to do, this is actually a little bit easier, I think, if you look at it in this form. So this means the same thing. So it means f of g of 2. Start on the inside. Find g of 2. So if you find g of 2, we're going to just plug 2 in for that x, and we get the square root of 3. All right, we're not done. That's what g of 2 is. So now we're down to f of the square root of 3. All right, you with me? So we're starting on the inside, find g of 2. So take g, plug in the 2, evaluate. That's what we get for g of 2. Now we're going to find f of that value. So we're going to take that and plug it into that x squared. So f of the square root of 3 is equal to square root of 3 squared minus 2. So again, just plugging it straight in that f of x, that function there. So notice again, I'm putting that in parentheses. Anytime we plug in, it's a good idea to put in parentheses so that you can see exactly what's being plugged in and see what the operations around that are. All right, square root of 3 squared is just 3, as we talked about in the last lesson. And then 3 minus 2 is equal to 1. And that's it. All right, so what if we were asked to find g of f of x? Which again, remember that this is, I'm sorry, not x, 2. We could do x, but we're going to do 2. We could also write this as g of f of 2. And so here we're starting with the f of 2 first. So f of 2 would be 2 squared minus 2, which is equal to 4 minus 2, which is 2. And then we can, so now we know that f of 2 is just equal to 2. So now I have g of 2. And I can just plug that directly in. And we actually already found g of 2 in the previous one. So g is equal to the square root of 2 plus 1, which is the square root of 3. I should have written that as, which is the square root of 3. All right, so that's composition. So with composition of function, you start on the inside and work your way out. And even if we had been, I mentioned a minute ago, like if this was g of f of x, we would just take f of x and plug that expression in here. You actually won't have to do that, but that is a useful thing with composition to know how to do. All right, the last thing is finding whether two functions are inverses of one another. So if f of g of x equals x and g of f of x equals x, then f and g are inverses. So inverses, what that really means is like if you have an equation y equals x plus 1, to find the inverse you actually switch the y and the x. It's just taking the y and x and switching them. So that'd be x equals y plus 1. You're not going to actually have to find inverses, but we want to be able to identify them. So if you were asked to determine if two functions are inverses, so let's see, if we want to know are f of x equals 3x minus 7 and g of x equals x plus 7 over 3 inverses. So what I'm going to do is I'm going to evaluate these using, I'm going to see if I get x. I'm going to plug this in to g and see if I get x. I'm going to plug this into f and see if I get x. So I'm basically, for f of g of x, I'm going to take this whole thing here and I'm going to plug it in for x right there. So I'm going to get 3 times x plus 7 over 3 minus 7. So this is, it's like 3x minus 7, but instead of x, I see this thing, the x plus 7 over 3. And then evaluate. Now this is multiplication. This is understood to be over 1, so those are like factors and cancel. And I'll get x plus 7 minus 7, which is equal to x. So far we're good. We want to do the other way too though. G of f of x. And so this one, I'm going to do the opposite. I'm going to take this and plug it into that x. So instead of x plus 7, it's going to be 3x minus 7 plus 7 over 3. So again, it's this exact thing, except I see the 3x minus 7 instead of that x. All right, then evaluating, those 7's are going to cancel out, and I'll be left with 3x over 3, which is indeed equal to x. So these are inverses, and that's how we find inverses. All right, so that's composition and other operations of functions, as well as whether two functions are inverses of one another. So that's it for this one.